India currently imports roughly 85% of its crude oil. This massive reliance on foreign energy markets exposes the entire domestic economy to the volatility of global geopolitics and price shocks. This chart illustrates the government's aggressive countermeasure, the E20 mandate. The policy requires all petrol to be blended with 20% domestically produced ethanol. Originally scheduled for 2030, this target was pushed forward to 2025, triggering a massive surge in domestic ethanol production from 400 million to 6.7 billion liters. By looking at the widening gap between these two metrics, we can quantify the immediate macroeconomic success of this transition. By substituting imported crude with domestic ethanol, India has retained over 1.36 trillion rupees, roughly $28 billion, in foreign exchange reserves. State officials point to these numbers as proof of a policy masterstroke. They argue the blending program simultaneously creates a guaranteed revenue stream for rural farmers while driving the nation toward its global clean energy commitments. And strictly at the macro level, the data supports this. Blending ethanol with petrol does result in a measurable reduction in baseline carbon emissions from tailpipes. But the core objective here is strategic autonomy. The state is actively building a buffer against foreign oil cartels by ensuring a critical percentage of its energy supply is produced entirely within its own borders. Yet, this top-down triumph masks a severe crisis unfolding at the micro level. When this new chemical blend actually leaves the pump and enters the existing mechanical and agricultural infrastructure, the system begins to fracture. Consumers are dealing with widespread mechanical breakdowns and voided warranties. At the same time, the aggressive demand for crops is severely depleting agricultural groundwater, while unregulated distillation zones are choking under intense industrial smog. To understand why this is happening, we have to trace a single drop of E20 fuel backward, starting from the exhaust pipe of a consumer vehicle all the way back to the agricultural fields where it was grown. Following this supply chain in reverse exposes the hidden thermodynamic, agricultural, and environmental costs of forcing a rapid green transition. It reveals that national energy sovereignty is currently being subsidized. The state is extracting the necessary resources and stability from politically marginalized regions and uninformed drivers to balance the federal ledger. We begin at the very end of the supply chain, the internal combustion engine of an everyday commuter vehicle. This animation shows the combustion cycle, highlighting a metric called calorific value. This is the amount of usable energy extracted from a given volume of fuel. Because ethanol inherently contains less energy per liter than pure petrol, the resulting combustion yields a weaker kinetic output. For drivers of new, compliant cars, this translates to a 1 to 2% loss in total mileage. For older cars, the efficiency drop is much steeper. In both scenarios, consumers pay the same price at the pump for less power. But ethanol is also hygroscopic, meaning it actively attracts and absorbs moisture from the air. This creates a severe material science conflict. Over 75% of the vehicles currently on Indian roads are legacy models, not designed to handle this moisture. The water-rich ethanol aggressively degrades older elastomers, rubber hoses, and plastic seals within the fuel system. As these components break down over 10 to 20,000 kilometers of regular driving, the resulting debris flows directly into the engine, causing severe clogs in the fuel pumps and injectors. When these engines inevitably fail, consumers discover a massive liability gap. Major insurance providers have begun classifying engine damage from E20 in non-compliant cars as owner negligence, voiding their coverage entirely. Yet these owners have no practical way to opt out and protect their vehicles. Unblended E0 petrol is either completely unavailable at local stations or priced 40 to 50% higher than the mandated blend. The E20 mandate effectively functions as a hidden tax. The government is transferring the physical and financial friction of its green transition directly onto the consumer through accelerated mechanical decay and voided warranties. Moving one step back up the supply chain brings us to the industrial distillation plants, where the raw ethanol is actually refined. This wireframe maps the topography of Byrnihat, a small industrial town on the Assam-Meghalaya border. It recently earned the distinction of being the most polluted metropolitan area in the world. As industries burn material, the resulting emissions are physically trapped inside its bowl-shaped topography. The World Health Organization recommends a maximum PM2.5 exposure limit of 5. Byrnihat recently recorded an annual average of 128.2. This toxicity is the direct output of roughly 80 heavy industries clustered in a small geographic footprint, which includes the facilities actively producing the ethanol mandated by the government. The air's particulate density is so severe that local drone sensors regularly misidentify the smog as a solid physical obstacle and refuse to fly. The human cost of this production is exact. Between 2022 and 2024, the town recorded a 77% increase in localized respiratory diseases. This continues without intervention because of a strict jurisdictional loophole. The factories technically reside inside Rathalaya's regulatory borders, but they operate primarily to serve the economic expansion of neighboring Assam, leaving accountability entirely diffused between the two states. This dynamic operates as a form of domestic green colonialism. To secure clean, blended fuel for vehicles driving through wealthy urban centers, the supply chain relies on unregulated industrial sacrifice zones, effectively exporting the pollution to marginalized tribal populations. Tracing the supply chain to its absolute origin brings us to the agricultural fields. This is where the raw inputs for first-generation, or 1G, ethanol are grown. This flow diagram illustrates the brutal thermodynamic cost of converting organic crops into combustible fuel. The process demands an astronomical input of fresh water to yield a viable output. To produce a single ton of sugarcane, the soil requires 60 to 70 tons of water. By the time the crop is harvested and processed, producing just 1 liter of usable ethanol will have consumed roughly 3,630 liters of fresh water. State data from the Central Groundwater Board confirms that sugarcane-heavy districts in Maharashtra are now experiencing severe, rapid groundwater depletion to meet these industrial quotas. Because government ethanol contracts offer fixed, lucrative pricing, farmers are financially incentivized to divert their yields entirely away from the consumer food market and sell directly to the energy sector. The shock to the food supply is already measurable. India was historically a net exporter of maize. But in 2024, to cover the domestic shortfalls caused by this diversion, maize imports skyrocketed by 7,940%, reaching nearly 1 million tons. The aggressive pursuit of fuel sovereignty is directly cannibalizing the country's domestic food security and irreversibly draining its finite aquifer reserves. If the E20 mandate is fracturing the domestic supply chain on so many levels, we have to ask how the exact same fuel policy is widely considered a massive success in other developing nations. Brazil stands as the global standard for ethanol integration, maintaining a national fleet that seamlessly runs on high-percentage blends without the mechanical decay or agricultural collapse seen in India. This timeline exposes the implementation asymmetry between the two nations. Brazil spent 4 decades slowly engineering a native flex fuel infrastructure from the ground up. In contrast, India compressed its entire mandate into a rigid 3-year rollout. Brazil used that time to ensure over 80% of its vehicles were flex fuel compatible. When a Brazilian driver pulls up to the pump, they have the choice between E27 and 100% pure ethanol, and their engines are specifically calibrated to handle both. India's current crisis is not a failure of biofuels as a concept. It is a failure of compressed policy execution, an attempt to force a rapid transition onto an agricultural and engineering ecosystem that was never given the time to adapt. The technical resolution to this bottleneck requires abandoning first-generation food crops entirely and pivoting to second-generation, or 2G, ethanol. This process relies strictly on agricultural waste, like dry stalks and husks, rather than consumable grain. By processing the physical waste that farmers would otherwise burn, the system extracts energy without demanding additional water or arable land. This shift preserves the macroeconomic goal of reducing crude oil imports, but it does so without cannibalizing the domestic food supply or collapsing regional water tables. True strategic autonomy cannot be achieved by merely shifting a nation's dependency from foreign oil cartels to its own marginalized ecological zones and aquifers. Real sustainability requires an infrastructure-first approach, where the underlying systems are built before the mandate is enforced.